There are two terms called multi-threading and hyper-threading that are similar to each other and yet slightly different, and they're very difficult to visualize. As a matter of fact, the idea of a thread is very difficult to visualize. Now, I know you keep hearing these terms, you've read about them, you've probably heard about them in other classes, and they're difficult for you to imagine. So I'm going to do my best to try to explain them, and the problem is that it gets a little fuzzy when you start trying to break it down too much. This is like trying to define something, and the more you try to define it, the more you have to keep adding an exception over here and an exception over there and so on. So let's just try to put it together as best we can. Multi-threading, as you have here, is the ability to run two or more processes at the same time. But now what they've left out there is on a single CPU. So you have one CPU, and it can take a thread. Now a thread is a sequence of instructions, and it can run, it can break it into sub-threads. Now that's not going to make sense here in just a minute, but for now, just go with me. You can break it into sub-threads and run those two sub-threads side by side with each other. Now, some of the parts of that CPU have to be duplicated for this to work. A multi-threading CPU has to have, for example, at least two sets of registers, so that one thread can use one set of registers and one thread can use another set of registers. And yet there are other parts of that CPU that it's sharing, and it's switching back and forth between, for example, the controller. So it's switching back and forth in the controller so that it runs a little bit on one set of registers, it runs a little bit on another set of registers. Now, I said that it breaks it into these subthreads and runs those, and here's where it's going to get tricky. A thread, by definition here, is the smallest piece of computer code that can be independently scheduled for execution. Well, if it's the smallest piece that can be independently scheduled for execution, how can you break it into subthreads? Well, the trick there is the scheduling. So it's the smallest piece that can be scheduled for execution, but during the execution, it can be broken up even farther. Now let's talk about hyperthreading. Hyperthreading is a specific Intel technology. It didn't come around until the 2000s, whereas multithreading was around, oh my goodness, 1960s or earlier. So hyperthreading is the idea of allowing two threads to run simultaneously on a CPU such that it appears that that CPU is actually more than one CPU, more than one core, I should say. Now, it sounds like it's actually got a duplicate everything. Duplicate controller, duplicate registers, and so on. It certainly does have duplicate registers, just like multi-threading. But to be honest, it does not have duplicate everything. There are still parts of the CPU in hyperthreading that have to be shared. But in this case, it's not switching back and forth to the extent that multi-threading does. Now this is where it gets a little bit fuzzy, because when you really start to try to define it, multi-threading and hyperthreading look very, very similar. Now here's the one thing I can tell you about hyperthreading that you may notice, and that is that if you have hyperthreading, you have what appears to be more cores on your computer than it actually has. So for example, I have a 16 core computer, but if I look at how many cores I have, it says that I have 32. So that's hyperthreading. It appears to have more CPUs than it actually has. However, it is not the same as actually having 32 CPUs. Again, there is some sharing going on. As a matter of fact, it's not even exactly the same as having 32 cores, because there is some sharing going on, and that sharing is going to slow us down a little bit. Now, I hope that helps to put some of this together. Again, it's confusing. It always will be confusing because as we begin to use these terms, they sort of blend into each other. But that's the best that I can do for right now. Thanks for listening.